Hi friends, in this video we're going to be going over how to do heparin medication calculations using dimensional analysis. If you haven't already, I suggest going to watch my regular medications calculations using dimensional analysis before you watch this one, because heparin ones can get pretty tricky. We're going to be going over 3 different problems, and the hardest one is the one we are going to be doing last. We're going to work our way up. Let's get into the first problem. The doctor orders IV heparin drip at 12 units kg per hour to give a loading dose of 60 units kg IV. The heparin bag says 25,000 units per 250 ml. The patient weighs 190 lbs. What is the flow rate? So ml per hour. So let's figure out what our O, H, and X is. So O is order, H is for what we have, and X is for what we want to figure out. So what we want to figure out is how many ml per hour. The order is 12 units per kg per hour. And then what we have, we know he's 190 lbs, and then that's a comma. We know that we have the heparin bag that says 25,000 units per 250 ml. Again, let's start with what we want. So we want our ml per hour. Writing it like this is less confusing than how we did it up here. So ml per hour equals, let's find our mLs in here, and we have it right here. So we're going to do 250 ml, erase that. Okay, 250 ml over 25,000 units. Now we want to get rid of the units, so we're going to find our units up here, and it's right here. So it's times 12 units. And then you're going to put the time up here, hours, since we want to keep the hours, but we're going to want to get rid of our kg down here. So over kg times, so we're going to want to get rid of that kg. We look over at our data and what we have, and we don't have kg, but we have something in weight. It's 190 pounds. So we're going to want to convert that to kilograms. So 1 kg over 2.2 lbs, because in 1 kg there's 2.2 pounds. And then we're going to times that by our 190 pounds. And then we have our placeholder because it's not paired with anything. Now we multiply across the top. So 250 times 12 times 1 times 190 equals 570,000 over times 25,000 by 1 by 2.2 by 1. That's going to equal our 55,000. Now we divide that out, and I get 10.3636364. It keeps going, but we're going to round, so we'll round from here. So we go 1 over, that's above 5, so we will round up here. So that about equals 10.4 Don't forget to put the units in your answer or it's a med error. So 10.4 ml per hour. Now, I know some of you are wondering, why does it talk about a loading bolus up here? So we would do something with this if there was another part of this question asking how many units of bolus that we would give. We're going to be going over that in a future problem. I believe it's the next problem. Excuse me, it's actually the last problem we will be going over. Part of it will be finding the bolus. Problem number 2, this one's probably the easiest. The patient has a heparin drip running at 22 ml per hour. The heparin bag reads 12,500 units per 250 ml. How many units per hour are they getting? So we are solving for units. And yes, you have to spell out units every time or it's a med error, because just putting a U could be mistaken for another number like 0. Okay, units per hour, and then what we have is what's the heparin bag, so 12500 units per 250 mLs. And then the order, of course, is our 22 ml per hour. So we start off with what we want to end up with. So we'll put units per hour equals, we want to find something with hours, which we have it up here. So 1 hour over 22 ml times, let's get rid of the ml, we have it there, so 250 ml over 12,500 units. Okay. So we have our mLs cancel out and we have our hours and units, which is what we want. So now we multiply across on both the top and bottom. So 250, 1 times 250 is 250, and then 22 times 12,500. So I just realized I made a mistake, which is good for learning experience. You guys don't do it and you can recognize when you see it. So you see how it's units up here and hours down here? When I started writing my problem, I accidentally put hours up here and it's supposed to be units up here. So let me rewrite it real quick. Okay, it is rewritten in the correct format now. You see how units here and units here. Okay, so now we multiply across, and 12,500 times 22 is 275,000, and then 250 times 1, of course, is 250. Divide that out, and we will get 1,100 units per hour. Okay, now we're on to the more complex heparin calculations. So the patient's PTT is 42, that's the prothrombin time. Per protocol, the heparin drip needs to increase by 2 units, so increase by 2 units kg per hour, and administer 30 units kg IV bolus. You'll recheck the PTT in 6 hours. Okay, not important for us right now. The patient is currently getting a heparin drip of 16 units kg per hour from a bag that reads 25,000 units per 250 ml. The patient weighs 160 lbs. How many units will they receive as a bolus? What will you change the... Okay, so we want to know how much we'll give as a bolus. What will you change the flow rate to? Okay, that's the ml per hour. Alright, so we're going to need a lot of room for this, so I'm going to shrink this text up here and we'll get into it. Okay, so I have my O, my order, my H, what I have, and X kind of up top there, so we can kind of squeeze as much room as we can out of the screen. So we'll start with our orders. We have 2 of them, so this is going to be a 2-part problem. So our first X will be our units for our bolus. And then our second X will be our new flow rate, which will be in ml per hour. What we have is our patient's weight, which is the 160 pounds. And then we also have what the heparin bag reads. So that is 25,000 units per 250 ml. Okay, and we have quite a few things that I like to put in the order section. So first off, we need to increase by 2 units kg per hour. Then we also have the 30 unit kg for our bolus, and then I also put what our patient is currently on, so that is 16 units per kg per hour. Alright, so I changed the color for blue for our bolus so it doesn't get confusing with all the math on the screen. So with our bolus, it's kind of more common sense type stuff, not super dimensional analysis, but sometimes that happens. So if you see up here, it's 30 units kg IV bolus, so that's 30 units of our heparin per kg of the patient. So we have the patient's weight in pounds, so we just need to convert pounds into kg. So he is 160 pounds. We're going to have our placeholder there. Times, okay. Here, we're going to do it this way. It's a little less confusing. So we want it in kgs, so kg equals, so 1 kg is equal to 2.2 pounds. So we're going to times this by our guy's weight, so that's going to be 160 pounds with our placeholder. Now we times across the top and times across the bottom, which equals 160 over 2.2, and you divide that out and we get 72.7272. Repeating, since this is now his weight in kg, we can go ahead and times it by the 30 units. This is where it gets a little less dimensional analysis and a little more just regular math. Okay, and then that comes out to 2181.8181, but we're just going to round and say it's 2181.8 units for our bolus. Now that we found out what our bolus is, I like to go ahead and cross out bolus up here because we figured it out, and cross out the order over here. Okay, now for the flow rate, I switched to green, again, so it's a little less confusing. So to start off, if you read the question, we have per protocol, the heparin drip needs to increase by 2 units per kg per hour to what the patient is currently getting. So we're going to go ahead and do that before we get into the rest of it. So over here, 2 unit kg per hour plus 16 unit kg per hour, and that equals 18 unit kg per hour. Now, since we've got these orders condensed here, I can cross them out, and this will be our new O right there. Now let's get into dimensional analysis of it. So we want our ml per hour, so ml per hour here equals, let's find our ml, so okay, go up here, we have our 250 ml right there, so we're going to do 250 ml over 25,000 units. Okay, now we want to get rid of the units, so where do we have our units? We have them right here in our condensed order, so units there, so we're going to do 18 units per, so we're going to want to keep the hour here since it's going to be in our answer, so we're going to put it up here with the units, and then we're going to have kg down here because that's what we want to get rid of. So now we need to find some weight. There's 2 ways you could go about this. You could go up here and you could see, okay, we already converted his weight into kg here, and we could just use that, and we would put it over 1, and then we would multiply across like we usually do. I'm going to go ahead and do it like we haven't already figured this out, just in case if you get a question like this and it doesn't have you figure that out beforehand. So we have pounds, but we want to go to kilograms, so here's our conversion, 1 kilogram over 2.2 pounds times what we know, 160 lbs, and then we have our placeholder. Okay, now we'll multiply across, and we get 720,000, multiply across the bottom, and we get 55,000, and we divide that out, and we will get 13.09. We'll go ahead and round that. We don't need to worry about this. This is below 5, so we're just going to round it to 13 ml per hour. So now that's our new flow rate, and we got rid of this x. So now we solved everything we needed to solve. If you haven't already watched the regular medication calculation video, I highly suggest it. I'll link it down below. Please comment any questions, concerns, or helpful study tips. Don't forget to like and subscribe. Thank you for watching, and I'll see you next time.